and the best practices around this. And before we go into the forward-looking things here, let's take a look at how applications have been deployed in the past and will be installed on your device anyways. So what happens is you have the APK, which is the application packaging file, which most of you should be somewhat familiar with. It holds your resources, code, and some meta information. And that recently turned 10 years old. Over those 10 years and over time, the application size grew. So that means that your on-device installed applications have increased in size. For every 6 megabytes that your application increases in size, you lose about 1.6% of your user base. That is one of the things that we found. And that is not just, that's just the average. So for countries like Japan, this might be roughly by about 0.5%, but for countries like India or Brazil, you're more in the 2 to 2.5% of users that you lose for every 6 megabytes that your users install on device. And we saw this, and we thought about what can we do about this. On the one hand, we can educate developers to make sure that they use, for example, vector drawables. On the other hand, to make sure that they use general resources that are just tailored to the user's device. But there's only so much you as a developer can do without us as the provider of the platform supporting you. So that's why at Google I/O we introduced Android App Bundles. Android App Bundles is a publishing format that allows us to do a couple of more things than just installing everything on one device. It's a publishing format, so that means it's a different thing to what gets installed on your device. And generally what it looks like is you have your app bundle that has a folder with a bit more metadata and all the resources, assets, code, and everything that was in the APK already. So when we look at this, this could be a setup of an application which has several drawable densities, has, in this case, a little bit of native code as well for different CPU architectures. And on a device, what would happen for an application that gets deployed with what happens is for the app bundle, we are now able to separate out multiple APKs of that. So it's not just one APK that can be installed on a device, but we have multiple of those, which is really cool. So for each of those display densities, we have this also for the CPU architectures. And there's also a master APK which contains things that we couldn't separate out. So, for example, if you have some resources that are specific to countries, to languages, or to, say, smallest width identifiers or things like that, those get still packaged in your master APK. How do we do this? With a tool called Bundle Tool. That's what Android Studio uses. That's what you can use on the command line. It is available on GitHub. You can use it from the SDK manager. You can download it there, and then you can run it locally. Once you use Bundle Tool, what happens? The app bundle gets built. You can't install that on device already. So from that, we generate APKs, an APKs file that is the APK set, which contains all the APKs that you could install on a user's device. From there, we then extract the APKs with an extract APKs command. You could just go and unzip the APKs file and look for the APKs that you want, but through a spec file, we can actually just extract the APK files that you need for your device, which you then get and use ADB or Android Studio. You can install that on device already. This is what you can do locally, and that's the same way that the Play Store does this when you upload an app bundle to the Play Store. It uses the same tool and the same mechanism. So there's no discrepancy here. And you could essentially do that same mechanism in any other store that would implement this. We have a sample available that uses this, which is Plaid. We have been using that for a couple of things. One of them is to demonstrate and showcase modularization and how we can use app bundles to have massive file size savings. So by just enabling app bundles, which instead of emitting an APK, and uploading that to the Play Store, we create an app bundle, upload that to the Play Store. We have about 2/3 of file size savings. Notice that the density size, the small red bar, is very small for us. This is because we already use vector drawables quite heavily. That means that other apps might have a larger gain on that end, but on the ABI size for our CPU architectures, we have a massive gain. So the lower bar here is that we stripped out a massive chunk because we don't have to install it on a device. So this is for a device with XX HDPI and ARM v7A architecture would be the installation afterwards. We didn't have to do any code changes here. So that is a prerequisite on this. We already get these savings without having to change any of our code. So far, there is no reason why not to try this and figure out what it can do for you for now. And it makes you a better citizen on the platform because you save your users data, you save your users for data through the network as well as on device. With that, and on top of that, we have another feature called dynamic feature modules. When you bundle those, when you create dynamic feature modules, those get bundled into the app bundle just the same way as the base module. There's multiple modules that can depend on the base module. And inside the module, it's all just folders that contain pretty much the same information as the base module. So for an app and for Plaid, what we did is we initially had our app module on Gradle, which we then figured out what can we do to split out dynamic feature modules. And we started with the easiest, which is a very small feature to just get to know the ropes and know how we can do this. One of them was using the about feature. That is just an about screen. It has very little dependencies between other features. So just extracting that was a fairly straightforward approach. Then we took another one, which is a search, put that into a dynamic feature module, and our news sources for designer news and Dribble, which I'll reference later on in the talk quite heavily. We pulled all of those out of the app bundle, out of our application into separate modules. So now what we would install on a user's device is still the base module, the base APK for those three different configurations, the master, the native part, as well as our density dependent part. And then for each of our modules, we do the same. But there is no native code in those modules because the dependency is only in the core. In the base module, we have our different APKs that we install on a user's device. With that, we also have one big feature that we could use is the build time improved massively after we've done this. So there's a couple of ways how this worked. Just because we have smaller deployments, we get those improvements. The easiest way to do this for your application after you have modularized it is to parallelize. So you go to the Gradle properties and just set the flag parallel to true, which in turn allows Gradle to take all the configuration and all the Gradle modules that are available and spin up a thread for them and start compiling them in parallel. So that means all the ones that are separate from one another, where there's no cross dependencies, can be compiled at the same time. This is really cool because it can cut down the compilation time, even the clean compilation time, quite a bit. So with that, we have all those modules. And if we wouldn't parallelize, we would still have to build everything. But since we modularized, at some point, we just have to build a single module. And that also speeds up our installation time and our deployment time to the device while we develop quite massively, because all the other parts are already fully compiled, and all we have to care about is, in this case, a very tiny about module. So testing is a thing that is close to a lot of developers' hearts. So I want to notice one key thing that we have found when testing dynamic feature modules in a parallelized world. Firstly, well, you know how the setup works. You put all your test code in the Android test or in the test folder. Same works for dynamic feature modules. So you want to have them as close to the feature as you possibly can. So the unit test actually is part of the unit that you want to test against. Same goes for the instrumentation tests in the Android test folder. For unit tests, this is really cool because we can make use of the parallelized builds. So all the builds, all the features can be, all the unit tests can be run in parallel. So that speeds up your testing time even more so. It gets a bit more interesting when you want to run connected Android tests. So when you want to run connected Android tests, what happens is that everything gets run in parallel. So all the modules get compiled, all your tests get compiled, and then Gradle thinks, oh, this is cool. I want my task to finish. So it just installs the tests on the device. Then the second one goes on and installs the task installs the app, the module that it wants to test, as well as the test on the device. But before that, it uninstalls all the previously installed ones. So that means your first tests will never finish because there's nothing to test. And you run into loads of weird problems with that. It took me a while to figure out that there's one easy way and one simple trick to avoid this. We just set parallel to false, which is cool. Now this works, but we now lost all our gains that we had before. We lost all our build time improvements that we gained through parallelization. So another way to do this is you can test your features independently while still keeping parallel to true. So you just run, after you implement something, write a test for a single module, you just run the tests for this one module with a connected ender test on the module itself. This is cool during development, but for your CI server, for example, or if you want to run the full test suite, you don't always want to type those 4, or say you have 10, 20 different modules that you want to test. This just gets very tedious to maintain. So the easiest way is to just say, at invocation, just say, add the flag no parallel. That means that the connected ender tests are being run not in parallel, but in sequence. This allows you to run tests as you are used to it, and you will receive the same results that you had before, without having to go through the headache that you can run into when you're wondering why all those tests fail at various stages and various reasons. So with that, we talked a little bit about Android app bundles and how you can use them by just using the bundle tool to drastically reduce your file size on device and over the wire. We touched on dynamic feature modules, which will be installed at install time. We also touched a bit about build time improvements and how you can use testing with the dynamic feature modules. One of the features that is being enabled through dynamic feature modules is on-demand delivery. There's a bit of confusion here, so if you use dynamic feature modules as a standalone, you don't have to care for on-demand delivery initially. For Plaid, what we do is we have those dynamic feature modules, but we don't use on-demand delivery as of now, just because we don't have the need for it at this point. But we already went the steps up to the point where we could, at some point, enable on-demand delivery. On-demand delivery essentially means that you, later on, through an API, have the possibility to download features as you need them. So with that, let me introduce you to a recipe finder app that has recipes that you can look at, which it also has an onboarding and a recipe list. And there's also a feature that is called My Recipes, which is not installed initially. And in the end, you could maybe just buy premium features that we could add on later on as well. So if you install a feature, there's 2 things. One of them is the API. The other one is the UX of that. So for the UX, once the user taps on that little plus down here, what we could do is we could just show, oh, this feature is now being installed, so just wait a moment until it's installed, and then you can use it. This works well for small features, but if the Play Store decides that your app has downloaded quite a few features already, and the user should get an actual notification, then the Play Store might decide to trigger a dialog, which says, this app is now downloading a new feature. User, are you sure you want this to happen? So those are your steps on the UX side of you from this. You can also download features ahead of time. So once you know that the user might want to use this later on, you can already download this in the background, and you don't have to display it to the user, as long as you don't hit this speed bump. And generally, how do you enable this from your app? It's fairly straightforward. In your Android manifest, all you have to set is the distribution here, and you set the on-demand flag, the on-demand attribute to true. Before that, it was false. Now with true, what happens is that the Play Store the Play Store does not download this feature initially at install time. So your users only install the core of the application, and all the features that you set to true for on-demand, you have to care for when to download them. How do you do this? For that, we have the Play Core API, which is currently at version 1.4. You use that as a dependency, and from there, what you do is you create a request, add the module by name, and then you have your request. And then with the split install manager, you request the installation. You can request installation immediately. You can request deferred installation. Also, a cool feature is you can request uninstallation. I'll show you a fun thing about that later on. That is the easy bit. The bit that's a bit more tricky, because there's a flow that you have to go through, is the split install state updated listener. It has a couple of states, so let's go through the path here. I'm not going to show the code here. I'm just going to show you the states that I'm going to discuss a bit about how they affect your app. So firstly, once you say you want to request a feature to be installed, you get pending as a result. Pending says, well, we're happy, we're on the way to download, this is fine. From there, you go to downloading and download it. So that is the states that you want to go through. This is the happy path. Once the feature has been downloaded, it's on your device, but not yet installed. This is where the next two states come in. That's installing and installed. Once your feature module is installed, you can start using it. But in many of these cases, you could also go through a not-so-happy path, which is failing. So you could fail for various reasons. You get response codes with that, which you can check and see why it failed. Also, you can, while you request it, you can also provide your users with a way to cancel your download of the feature. It's especially interesting if you have a very large feature and the user wants to have a possibility to cancel that. And one more thing on that is the dialog that I showed you earlier will give you the state requires user confirmation. So you have to deal with this in order to actually go through the pending state and actually being able to install your application. We show this in a sample that I link later on in the slides, and how to implement this listener. And let me just go through back to the app that I showed you just now. So we have the recipes app, which initially at install time has recipes, and there's My Recipes, which you can install later on. There's also a feature for onboarding and a premium feature as well. So let's go through the flow and how this could look like for a user that uses the app. One way that this could work is at the app installation time, we have only the onboarding, because that's what we need to get the user going, and the recipes installed. Once we finish the onboarding, we can use the split install manager to actually uninstall a module, because users onboarded, we don't need this any longer. That's a really cool way to also save your users' data and space on the device, and also make sure that your app is as lean as possible. Later on, the user clicks on the plus, wants to install a new feature, so they discover this feature, and you can just download and install it. And at some point, the user might be like, I go through an in-app purchase, and I buy another feature, so they can purchase the premium feature, which then gets downloaded and installed as the user actually needs it. This all works with a feature with an Android feature called the split APKs, which enables the whole way how those APKs get installed on the device. Also, another thing, who of you has used instant apps in the past? If you have not, there might be a couple of reasons. I know that it was a bit tricky to implement in the first place. We have changed that massively. So recently, we shipped the Android Dev Summit app. And the Android Dev Summit app is shipped as an app bundle with a single module. So we don't have dynamic feature modules on top of this. And how we enable this is by just setting a simple flag in here, instant to true. This allows us to listen to the URLs, and the Play Store then intercepts these URLs and allows us to download the instant app. We can also use the Play Store to link to that, and there's a Try Now button that the user can click. Adding a launch flag allows you to launch an application, an instant app, without the user having to install it, or without you having to add URLs in the first place. So creating an instant app is easy as this once you switch over to app bundles. But that's enough about how the technology underneath and how those things work. Let's talk a little bit about the thing that I read about quite a bit, and that is libraries and modularization. A lot of people talk about libraries, and they talk about libraries as they were, and about modularization, because it's an interesting topic to talk about. But libraries are libraries, and modules are modules. And modules is a heavily overloaded term. For Gradle, it's fine because it's modules all the way down. So you're technically correct when you talk about library development as modularization. But from what we're looking at from the Android point of view, modularization actually means that you have an application that can ship as separate and distinct modules. So to go into that a little bit more in detail, you have your application, and then you start pulling out a core as a library, and you pull down, but you still ship a single monolithic application. Then you take out a feature, you take out another feature, and even more features. And all those features somehow depend back on the core, and they have all this. But what it all ends up is, it still is one application that gets installed on your user's device. So while you have a little bit more separation in between those modules, and you have cleared up your things a bit, you still ship this one monolithic APK, so you don't get file size savings, and you don't get the possibility to later on have dynamic feature modules and the on-demand delivery enabled. You still can, at this point, already use app bundles, but let's take a look at why I think it's important to make this differentiation between library development and feature development, and modular development with the dynamic feature modules. So using dynamic feature modules, we have an app. We still have libraries that we pull down from and that still get shipped in the base application. But on top of that, we take out modules that then depend on the application. And we pull those out, and those can be shipped individually later on to the user. So that's why I think modularization from an Android point of view is about dynamic feature modules and not about libraries. So one of the really cool things about libraries, though, is, well, there's a plugin. So if you're wondering whether you're doing modules or libraries, if you use the library plugin, you're developing libraries. You still have the monolithic deployment. They can be reused in other apps, which is cool. If you make your libraries small enough, they can be reused and depended upon from another application. You could also have non-Android libraries. So you could have a pure Kotlin library, for example, which does not have any references to the Android framework. And it's the first step to proper modularization with dynamic feature modules. For dynamic feature modules, you use the dynamic feature plugin, and that's proper modular deployment, which enables delayed delivery through on-demand and instant apps. And the compiler is more clear about the boundaries that we have there, because I'll go into that a little bit more in detail, but generally, the feature module depends on your application, so the application can't directly call into your feature module. So let's go into that. You have your application, you have your library, and you have your feature module on top of that. The application depends on the library. That means the application can access all the code that is within the library. And on top of that, you have the dynamic feature plugin, which can access code from your library, maybe transitively, we'll go into that a bit, or directly from the application. So it can make use of that. Let's go a bit into Gradle, into how Gradle supports you with this. So one way to declare dependency in Gradle is using API. The API keyword essentially means that if you have a library declared as an API dependency within your app, it also can get included in the feature module. That means you have the library shipped as part of the application on a file level base, as part of the application module. So it gets compiled into that. And your feature then can depend as an implementation or API dependency on your application module. And that means that with this, transitively, the feature also can call the library module and can call code from there. This is really cool, really straightforward to implement. There's but one massive caveat on that. So let's take a look at what I mean here. So let's first clean everything, and then we bundle everything. So that means everything has to be recompiled as we would expect it to be. Then we introduce a change in the library. Again, or let's introduce a change in the application. Everything has to be recompiled as we expected. But if we make a change to the feature module, because it depends on the library and the button transitively, we still have to recompile everything. So anywhere you make a change, you still have to recompile everything. So be aware of this when you use the API keyword. While it's very easy to use and it's very tempting to use, you might not want to do this. What you could use instead is use implementation for the library. So that means that the library is not being exposed to your feature module. It still gets compiled into your application. It still gets compiled and shipped as that. And your build Gradle file for the feature could still depend on the app, but it cannot call the code from the library any longer. So if you want to use this, you either say that the library is also a dependency of the feature, or you just don't have the dependency at all. So let's take a look at how this improves our build. So we clean everything again, we bundle everything again, and we then introduce a change in the library. What happens is everything gets recompiled, as we expected. We make a change in the app, everything has to be recompiled. We make a change in the feature, only the feature has to be recompiled. So that means by using the implementation keyword over the API keyword, allows us to speed up build times here. So let's go for another fun thing that we can do when we use code-only dependencies. So there's a way to have dependencies that are marked as compile-only. A compile-only dependency is a dependency that can be shipped as part of the feature. And the app can depend on it without actually having the code in it, which means that the library is part of the feature module. It gets compiled into the feature module. The apps can still call code that is within the library because we just tell the compiler, this is fine, we know what we're doing here, and we ship this later on at some point. So what are the prerequisites to make this work? The library doesn't use a ComAndroid plugin, so the Kotlin plugin would be fine, Java plugin would be fine for that as well. The feature contains a library, and the app has to check the code for availability. So essentially what you have to do is you have to just gate your access to the library from your application module. So you just check whether the feature is installed. If it's installed, it's fine. And then you execute the code that is marked as a compile only. Otherwise, you download the feature. If you have a dynamic feature module with that, which is not using on-demand delivery, you don't have to do these checks. But the cool thing is you keep your application module lean and small and ship the library only as part of the feature that actually wants to deploy it with. So I talked a little bit about the problems that you might come up with when you want to call code from your application, from the feature within your application. So if you want to call code that is not in the application module, you can't, and it's in a feature module, you can't just say, feature module, give me this, because the compiler doesn't know where this feature module, what's up with the feature module and what's in there. So there's multiple ways that Android framework supports you to do this, and there's multiple ways that you can do this yourself. So the Android framework supports you with this, for example, for activities using URLs. You just start a new activity, pass in a URL, and the activity from the feature module gets launched. Same works if you add the hard dependency on that by just passing in the path and class name that you want to invoke. This is brittle. It works, because that's what the Android system does underneath anyways, but it's brittle, because if you make a change in the feature module, if you change the feature activity's name, then you have to also change it here. It's not the best solution, but it works. That's actually the way it's currently implemented in Plaid, so it's one step. And it's definitely a legitimate step to take, but it's not the best step to do this in the long run. So this is how it works if you want to start Android components, so services, or if you want to start activities. If you want to start things that are in context or don't extend from context, then you have to use a reflection. Well, you don't have to, but that's an easy way to do it. So you still have it's still brittle because it is reflecting upon a name that you pass in, but you then can instantiate it. If you make changes to that, it might break. So it works, but there's still room for improvement. So with this, let's take a look again at our application that I showed earlier. This is, again, the dependencies that we use in Plaid. Let's strip away all the things that we don't need for this. So we have our news sources, so in that case, designer news and Dribble, that depend on our application, and they provide a thing for a search. And for that search, we want to be able to call it without actually having to use reflection or without having to use provide any strings that we want to use the system to then look up internally. So let me show you how we did this. We have our three layers. So our core within the library. We have our application, which is where our app lives, and we have our feature module. So within the core, we create an interface, which we then implement in the feature module. So that allows us for the activity, for the app module to not know anything about the actual implementation of said interface. So that means that the code that we have to ship with the application is just the interface and not the implementation. Then from the activity, we can call send a broadcast using a broadcast receiver in the feature module, which then is able to provide us with the actual implementation and send that to a registry within the app. This allows us for a massive decoupling because we don't have to rely on a brittle mechanism anymore. So because it's a bit complicated, let's go through this in a bit of more of a flow. So we have our search activity in the application, which requests a search. In our feature module, we have a broadcast receiver, and we have the implementation of a feature service. In the application, we also have the search data, which is an interface, and we have the actual search data implementation, again, on top of that in the feature module. We use Dagger internally, so there's a core component, there's a couple of things. And in the application module, again, we have our registry. So let's go through the flow and how this works. So the search activity sends out a broadcast to the broadcast receiver. It just says, I want to know who can provide me with search results. The broadcast receiver in the feature module then starts a service. That said service then requests the search data, which is being held onto in that feature in the feature service. While it does this, it also retrieves the Dagger graph for the core component, which provides it with the registry, which is being held on. So our registry then can be requested from the feature service. We can hold on to that, and we can register the search data that we have got returned in the registry. Service then stops itself, and the registry then provides the search activity with the implementation of the search data back to the activity. So this punches through a couple of layers of our complexity here, and then we can use the search activity to just call on the functions of the search data, which are in the interface, and then we can use that to get an answer of it. And coming back to the slide from previously, we now have a fairly loose coupling here. The cool thing is we use the Android framework to provide us with all the mechanisms that we need. We have the broadcast receiver, and we use a service because we have a little bit of work to do to set everything up. So we're using platform features rather than using language features to get our implementations for that. So this is a really cool thing that is coming to Plaid very soon. There is already a draft pull request. We're still cleaning up a couple of those things. It is already fully working. We just want to make sure that it is a performance solution before we actually merge it in and share this in a more detailed way. But you already can take a look at it in the sample. With that, I want to talk a bit about how you can get started with modularizing your application before you actually go into developing dynamic feature modules or taking stuff out of there. So one of the things that you can do is name your resources by schemes or put them into files. So if you know that a feature is part of if you know that strings, for example, are only part of a feature, create a strings_feature name XML file. Put your resources in there. So later on, once you pull them actually out, you have already everything prepared for that. And structure your app by feature. So what's a feature? Usually I would say anything that on the user experience side, on the user UI side, your user can see, or on the development side, anything that provides your application with functionality. So those could be features. But from a dynamic feature module point of view, get started with the ones that the user sees and have them in not on-demand modules in the first place. So you don't have to deal with the states that you had that I showed you earlier. And then when you get started with the most simple feature that you have in your application. Within Plaid, we did this with the about feature, mainly because this doesn't have many cross dependencies. So that makes it fairly easy to just figure out what are the problems that we might run into, and also what are the good things that we learned over that. So over time, and iterate with your team on this. You can later on, after you've done this with the refactoring, introduce new features using this. Those new features then can already be deployed in a dynamic feature module. If you want to learn more on how we did this in Plaid, just take a look. It's already out there. If you go to plaidapp.io, you can download it and see how it actually works on your device. There's also loads of documentation out there. So we have documentation on instant apps and Android app bundles. Dynamic features is part of the Android app bundle documentation. And we have samples out there which all use Android app bundles underneath. So we use the dynamic feature module for all of these samples already. So with that, I was quicker than expected, but that is the content that I had to go through here today. So with that, thank you very much, and I'm very happy to take questions.